A very good afternoon, everyone. My name is Kabinesh Analaki Patmanathan. My matrix number is 01DKP23F1007. Today, I will begin our presentation by introducing the shear strake and its associate structure. The shear strake is the uppermost longitudinal strake of the side shell plating, positioned right at the edge of the deck. Unlike the other strakes, it is made thicker and stronger because it carries a much greater share of the ship's longitudinal strength. Now, why is it important? When a ship is at a sea, it is continuously exposed to wave action. As the ship passes over the crest and through of wave, the hull undergoes hogging. When the middle of the ship bends upward and sagging when the middle bends downward. Both of these causes large bending stresses along the length of the vessel. The shear strake acts like a reinforced edge beam that resists these stresses and helps the hull to maintain its shape. The shear strake does not work alone. It is supported by several attached structures such as the deck plating, which ties the whole deck together and transfers stresses. The second is frames and beams, which provide transverse stiffness and prevent buckling. And lastly, the gunwale bar, which reinforces the edge and prevents damage when the ship comes alongside a quay or during cargo operation. To put it simply, the shear strake and its connected members form a structural belt of strength at the deck edge. Without this reinforcement, the ship's hull girdle would be much weaker and more vulnerable to structural failure in heavy seas. As you guys can see, this is the sketch of the radius shear strake and attached structure. So we have deck plating, shear strake, and the frame, and the beam, and also the gunwale bar, which provide the edge reinforcement. That's all from me. Thank you.
A very good afternoon for everyone. My name is Devashana Analaki Mahendra and my metric number is 01DKP23F1020. Now I am going to describe about the stress concentration in the deck around hatch openings. Okay, let's move on to the topic of stress concentration at deck hatch openings, which is a major design concern in bulk carriers and cargo ships. These vessels we need larger rectangular hatch openings on the main deck so that cranes or conveyors can load and unloading bulk cargo quickly. However, cutting this large opening into the deck reduce the overall continuity of the deck structure. Since the main deck is the one of the important most important strength member of the hull grader, any disruption has serious consequences. The biggest structural problem occurs at the concern of the hedge. Corners of the hedge. These corners act as the point of stress concentration, where the flow of stress in the deck plating is suddenly interrupted. Instead of spread evenly, the stress gets concentrated in a very small region, making it a hotspot for cracks. Imagine bending a piece of paper with a sharp cutout. The crack will almost always start at a corner. The same principle applies here. If the corner is not designed carefully, fatigue cracks can form due to repeated wave loading, eventually leading to hull damage or even catastrophic failure. Furthermore, when hatch openings are cut, they are also interrupted the supporting framework below the deck, including both the longitudinal girders and the transverse beams. This weakens not just the deck but also the internal strength distribution of the ship. So, while hatch openings are operationally essential, they are represent a trade-off between functionality and structural strength. So that's why naval that's why designing reinforcement has a great part in naval architecture field. So we won't be we won't be facing any different types of failures or damage on ship's hull. Thank you. That's all from me.
Thank you. To finish our presentation, I'll explain how we can reduce stress concentration around hatch openings and summarize our findings. Naval architects uses a variety of techniques to make these weak points safer. Rounded corners instead of sharp ones. By curving the corners of the hatch, the stresses flow more smoothly and the risk of the crack is greatly reduced. Second one is doubler and coamings. Doublers are additional plating layers that strengthen the deck around the hatch, while coaming, raised vertical structure around the hatch opening, provide extra stiffness and help spread the loads. Reinforced welding techniques. Poor welding can leave behind residual stresses and weak points. By using advanced welding methods and inspection, we can ensure the strength is not compromised. In addition to this, proper maintenance and inspection routines are also critical. Even with good design, fatigue damage can occur over time. So regular checks help catch cracks early before they become dangerous. As I say, how we can avoid the become dangerous? So we have to do a regular check to help the catch cracks. To conclude our presentation today, the shear strength is vital in providing longitudinal strength to the ship's hull. What does it mean? So it's explained that it will provide a longitudinal strength and a resisting wave induced bending. Second is hatch openings. We have to have some hatch openings while necessary for operations. Introduce weak points and stress concentration that must be addressed. Through a careful design and reinforcement, we can balance operation needs with structural integrity, ensuring that modern ships remain both efficient and safe throughout their service life. That brings us to the end of our presentation. Thank you for listening. So we also have a reference like first one we got a Taylor DA 2000 which include the machine ship construction, and two Tupper, three Biren which explain the ship hydrostatic and stability, four and five Muhammad Razman Mena. And I have state in every slide which of the reference we used for the slide. For example, for slide 1, I've said there we used the reference 1 and 2 in brackets. So you guys could refer that. Thank you.